Today we're going to talk about the cognitive neuroscience of empathy. So I say you're a DevOps natural, right? And so what does that mean? Like you're a DevOps natural? Like what is this all about? And what I'm saying is we're talking about empathy, and John just talked about empathy in the last talk, so it's awesome. So I feel like he's queuing me up here. Empathy is innate. Empathy is a part of who we are. You can actually build your empathy muscles. Like you can work on this. There's all kinds of studies about how people have improved their empathy, and we'll actually talk about this a little bit. But empathy, people say, is at the core of DevOps, because with DevOps, we're trying to work as one team to deliver software for our customers, right? We want to do it fast. We want to do it with quality. We want to do all this stuff. But in order to do that, we need to work as one team. And so there's nothing about any one person that means that they can't be empathetic with others. Some people think that, you know, women are the only ones who can be empathetic and men can't do that, but that's completely not true. There's no scientific evidence for this whatsoever. As a matter of fact, they've done studies where they told men that women found men who were more sensitive, more attractive, and when they did a repeat of the empathy scale, the men's empathy went up. So, I mean, that's just like a tiny little nudge, and they were able to get that stuff to go up. So this is stuff that's really interesting to me. I was lucky enough to start off my career working at the National Institutes of Health in a neuroimaging laboratory. So all the pictures that you see on these slides, like this one that have a brain, that's my brain. As a research assistant, you spend a lot of time in the scanner as a let's call it normal control, I think is what they called it. I don't know if Calvin would agree that I was normal, but for whatever purposes, they felt like this was normal. So y'all get to see my brain. And empathy is a pretty big topic going on right now. This was from yesterday afternoon. Times says, without empathy, nothing works, by this chef who wants to feed the world through the pandemic. And the thing I loved about this quote from yesterday is that this is actually empathy. Like the fact that it says he wants to feed the world through the pandemic is one of the components of empathy that's required for us to actually have empathy. So this is a big deal with all the stuff that's going on right now, the fact that we're doing this conference online, the fact that people are at home. The world could use a lot more empathy. So it's a good time to be talking about this as well. And so kind of like a little bit of a warning or a preference or whatever you want to call it here is this is science. Science changes over time, right? I like to say biology is messy. We've got like, you know, blood flowing here and there and muscles pumping and all kinds of other crazy stuff. It's a little bit messy. And, you know, in science, we say that science advances one funeral at a time. Like it keeps marching forward, and old ideas have to die off and new ideas have to come in. And so some of the things I'm going to be talking about today, we'll talk about the old ideas, we'll talk about the new ideas, but just remember, this is a point in time, and things that we didn't understand about the brain maybe years ago, now we understand a lot better. And, you know, in 2 years, you might come up to me and be like, oh, I read this study, and, you know, that study that you were talking about is wrong. And that's okay. Like, there's nothing wrong with that. Like, we want to learn, like, as we go. So this might look a little funny, right? This looked pretty old or whatever. But neural models have changed over time, right? And what humans have tended to do over time is think about the brain in the way of the most advanced technological thing that they have at the time. So, like back in the day when clocks were the most advanced technological thing that there was, people used to describe the activity in the brain as the same way that they would describe the activity of a clock. Nowadays, what's our most, you know, our fanciest like machines or whatever are computers. So when we talk about brains, people talk about neural circuits and memory and all kinds of things that use these, you know, computer terms to describe the way that the brain works. But the brain's not a computer, right? And unlike, you know, this picture here, like where, you know, friendship is in the back of the brain and language is in the front of the brain, obviously the brain doesn't work exactly like that, but there are localities in the brain where things happen, and there are different parts of the brain that work together to have certain outcomes. And so back when I was working at NIH, the National Institutes of Health, I worked with this doctor, Dr. Mentis, brilliant guy, amazing. And he was telling us a story about when he was in his residency, and he got a call when he was at home that he needed to go into the emergency room because there was somebody there who had tried to take their own life with a firearm, and so they needed him to come and check this person out. So he said, okay, and he drives down to the hospital, goes into the emergency room, and looks around, and there's it's pretty empty, and there's just a bunch of people standing over in the corner around somebody or whatever, and everyone's laughing, and they're having a good time, and he's like, well, okay, this doesn't make a lot of sense. So he goes up to the nurse and he says, where's my patient? You paged me to come in here. I had to drive all the way down here. What's going on? And they're like, oh, that's your patient over there. And he's like, what? And it was the person who had the cluster of people around them who were all laughing. And it turns out that when this person had tried to hurt themselves, they had damaged their frontal lobes. And their frontal lobes are where we do things like make decisions about like what's a good decision. We do higher reasoning. Our frontal lobes don't even develop well into our 20s, which would explain like a lot of the behaviors people might do in their teenage years. But one of the things that the frontal lobes also is responsible for is knowing when to say dirty jokes in what situation. Like, and obviously a hospital situation is not the time to do that, but this person had no reminiscence of that or no understanding of that. And so they were telling like these incredibly dirty, obviously funny jokes or whatever to all the people who were gathered around. What we're trying to illustrate is that different parts of the brain actually have specific functions. And so when researchers are trying to do research on empathy and things like that, we're going to look for, not we, because I certainly would not consider myself anywhere near their caliber in any way, but we're going to look for ways that the brain is acting and where the brain is acting. And so when I said those pictures in the beginning were my brain, around that time we were developing, the world was developing a technique called functional magnetic resonance. And so this, you might hear the MR for like MRI machine. So anyone who's ever had their like knee checked out or shoulder or whatever, it's the same thing. It's an MRI machine, but they put people in these MRI machines and then they take pictures of their brain very, very, very quickly using the MRI machine. And then they piece that together. And what they're doing is they're using like the properties of our blood with like hemoglobin, having iron and things like that, to be able to determine where blood is flowing and how much blood is flowing to that area. So before we had fancy things like fMRI machines or MRI machines with doing functional magnetic resonance, we used to, and we still do, implant electrodes in the brains of monkeys, or when they do brain surgery, they even do this like with humans, not in the same exact way. But there's a story of that's real, whatever, from the early 90s about this lab in Parma, Italy. And so that's Parmesan cheese on your left there. So that's your mnemonic for remembering Parma, Italy. And there's a researcher named Vittorio Gillespie, and he's working with macaque monkeys, and that's a macaque monkey on the right. And he's got an electrode implanted in the what would be the equivalent in humans of like the premotor cortex, the area responsible for movement. And they're doing experiments or whatever, and Dr. Gillespie goes to take a break. And as the story goes, he sits down, he reaches for a piece of fruit, whether it's an apple or whatever it is. And when he reaches for this piece of fruit, the neurons in the motor cortex of the monkey fire. But the monkey's not reaching for anything. It's only Dr. Gillespie who's reaching for something. So why would the monkey's neurons for gross movement fire if it's Dr. Gillespie who's the one who's actually performing the gross movement? And so this was the discovery of what's called mirror neurons. And mirror neurons are these neurons that when they see an activity performed by somebody else, we have that neural activation ourselves. And there's lots of different kinds of mirror neurons. They don't just do things for like gross movement. They do things for like, for the things that you would imagine have intention, like grasping or tearing or things like that. And there's mirror neurons for visual things. There's mirror neurons for auditory things. right? And this is a part that's just built into our bodies. It's built into our neuroanatomy and our neurochemistry. It's a part of who we are. And so, you know, things like grasping is likely learned, right? But imitation happens even in babies. So anyone who's a parent who's ever had a young child knows that if you go up to a small child, to a baby, and you stick your tongue out at them, it is very likely that that baby will stick their tongue out back at you, right? That imitation. And so what we're kind of saying here is that this is a part of who we are, this ability to understand other people, this ability to connect with other people. We naturally build a social system between two entities. We have these feedback loops that are built in. We create, in essence, a shared mind. And this is part of what scientists call the default network. And so, look, I just activated all your mirror neurons. I mean, sorry, because, you know, I didn't ask you ahead of time, so this obviously has implications for free will, but, you know, this is important, right? We look at her and we, you know, we wonder, what are her emotions? How do you know what her emotions are? What is she thinking about? How would you know what she's thinking about? And so our default network spends its time trying to understand other humans. And this is the default network. This is what our brain is doing when we're not actively doing other things. We're trying to make connections to other people. So why? Like, why would evolution pick this idea of making connections to other people as sort of the default thing that we do? And it's, you know, essentially like a lot of things, it comes down to survival. So if I have a group of monkeys and they're sitting around at night and the tiger comes to take one of the monkeys and the monkeys, you know, don't do anything about it, and one of the monkeys gets taken away, then what happens the next night when the next monkey goes and the next monkey goes and the next monkey goes? But if when the tiger comes, the monkeys band together and they fight off the tiger, then we've ensured the survival of the group. And this concept of ensuring the survival of the group is a super strong part of our humanity and also of our anatomy and the things that are built into the way that that we're made. And so this desire for connection with other humans, to especially, you know, ultimately to preserve the group, is so strong that in the 1940s they did these experiments where they would show people these movies of paper cutouts, right? And in the, you know, movie, there's like this triangles and whatever, and they would ask people to describe what's going on in the movie. And people would ascribe intentions and anthropomorphization to the different shapes in the figure. They'd be like, oh no, like that big triangle is so mean. Why didn't they leave the little triangle alone? And what did the little circle do? I don't know what the thrilling conclusion of this is, but I'll post the slides later. You can probably look it up. But this is such a part of who we are that it really gives us, you know, this understanding of the default network, but it also gives us a great foundation for understanding empathy. And so I'll give you a second to read Dr. Lieberman's quote here, because this is really at the core of what we're going to talk about for the rest of the talk. All right, so this is a summarization of what you just read. If not everything there made sense, and we're going to go through it right now. So the models of empathy that we have nowadays are much more advanced than just simple mirroring, like simple mirror neurons. And this is a model of empathy that's being put forth by like Harvard, UCLA, Stanford. A lot of different labs are advancing this. And there's three components in this model of empathy. And so there's experience sharing, which is kind of what we talked about with mirror neurons, right? We want to understand what somebody else is feeling, and it turns out that we're actually experiencing it ourselves, as long as, you know, we don't have some kind of sociopathy or something like that, which is actually true. There's all kinds of studies about that as well. So there's experience sharing, and then there's this idea down here on the bottom right of pro-social concern. Some people call it empathic concern, but regardless, it's this idea that like it's not empathy unless we're motivated to help the other person. And so this is why I love that, Time magazine cover. The chef wants to feed the world. It's not enough that the chef sees the pain that's happening in the world during the pandemic, but the chef actually wants to help feed the world. He's motivated to help. And this is important for us, right? If the network engineering team has been up all night long fighting, some horrible outage, and then the sysadmins walk in the next day and they're like, whatevs, that's not empathy. And there's certainly not going to be a whole lot of DevOps happening in that situation. And obviously when I say DevOps, I mean DevOps in the global software development idea, not in the I'm a DevOps engineer idea. But this pro-social concern is really important. And the last component of this model is mentalizing. And mentalizing is recognizing that somebody else has a mind, to understand that there's mindfulness there. And if we don't recognize that mindfulness in other people, then we're not going to actually be able to do empathy. And so in different situations, we're going to have different proportions of these different components of the model. And that's good, because in certain situations, we're going to want to emphasize certain components of this model over others. And this idea of mentalizing is one of my favorite components of this model. This notion that other people have a mind and we can recognize that they're independent thinkers. And so Lear Hackle says, when we empathize with someone, we must first detect the mind that can feel pain. And so they did these experiments, or they do these experiments even, called the false belief paradigm or the Sally Ann test. And so in this experiment, we have Sally and we have Ann, and they're best friends, and they're playing with each other, and they're tossing a marble back and forth between them. And so at some point, Sally decides that she wants to go take a walk. And so they agree that they're gonna, she's gonna go take a walk, and Sally takes the marble that they've been playing with and puts it in her box. And then she goes off and takes a walk. And after she leaves the stage, Ann goes over and takes the marble out of Sally's box and puts it in Ann's box. And then Sally comes back and they ask the subjects in this experiment, where is Sally going to look for the marble? And all of us, generally are going to say, like, Sally's going to look in Sally's box, right? Because, we know that Sally left and Ann, moved the thing, but Sally doesn't know. But if you're under the age of 4 or in certain places on the autism spectrum, you will say that Sally is going to look at Ann's box. Why? Because you can't perceive the difference in mind between what you've experienced and what is happening on the stage. You don't recognize Sally as being an independent entity that has her own brain and her own perception of the world. To you, that perception of the world and your perception of the world are one and the same. And so it's interesting because this idea of mentalizing actually works even across teams. We'll talk about that in a second. But this idea of teams, right, is this idea of a group. This is like the group that we belong to. And so Gertner and DeVideo for years have been advancing this idea of the common in-group identity model. And this is talking about in-groups and out-groups, and how do we change that? So when we're talking about like DevOps, and we're talking about the network team, or the development team doesn't care about what's happening to the sysadmin team, how do we change that? How do we bring people together to work towards a common goal? And so we want to change this notion of the in-group and the out-group. And it's very easy for people to fall into these idea of groups. This is like a normal part of who we are. They did experiments where they put red or blue armbands on groups of people at random from a large group of people, right? And then they went and did tests and asked people about the red team or the blue team, whichever one they were on or whichever one they were not on. And people would say that people in their armband group were kinder, more attractive, more capable. I mean, this is from putting an armband on random people. So this group identity thing that we have is a huge part of who we are. And so if, I make my living as like a systems engineer, like this is part of my identity. This is part of who I am. And so how do we bring these people together? And so Allport has been advancing this idea since the 1950s called the contact hypothesis. And they've used it, you know, to try to make connections, like in-group connections between like Israelis and Palestinians and Protestants and Catholics in Northern Ireland. But what he says is, in order to facilitate this bringing people together, you have to have 4 things. You have to have equal status between the 2 groups. You have to have common goals. You have to be in a cooperative or interdependent setting, and they have to have support from authorities. And for me, like, you know, I would say that last one should be have support from management, right? If I want to get the developers and the engineers to understand that they're both working on one product, then they have to have equal status, common goals, be in a cooperative or interdependent setting, and have support from management that this is something that's going to happen. So like my example, you know, when I work with clients on like how to create high performing teams and how to improve their operations functions and the things that I do in my business, I tell them things like, put all the engineers who need to deliver this product in the same Jira project. They can have different boards for the work that they do, but they have to be inside the same project because they have to understand that the goal is to deliver the product. That product is what the goal is, and everybody needs to be aligned along that function. And so what do we know about empathy and mentalizing between groups? So these are some parts of the default network. It's missing the temporal parietal junction and some other stuff, but we know a couple of things. We know that we mentalize about groups in the same way that we mentalize about individuals. So we can actually, you know, think about people as a group that thinks together, and that we have research to prove that. We know that out-of-group members evoke less activation in the medial prefrontal cortex. That means we empathize less with people who are in our out groups, for people who are not part of the people that we work with. So we are not as easily making those connections, right? What does that mean for silos? We have a lower threshold to mind perception for in-group members unless an out-group member is considered a threat. So if somebody's chasing after you with a knife, you don't think that there's just some mindless zombie. Like, you're ascribing a lot of intentionality to that activity right there. But, you know, we have a much easier time empathizing with people who are in group. This is why silos are bad, right? This is why cross-functional teams, when, you know, if you can staff it, or, you know, if you're a startup or a small company, you're going to have cross-functional teams naturally. This is why they perform better, right? We have a lower threshold to mind perception and thus a lower threshold to empathy with people who are in our in-group. So, you know, we can't have a DevOps talk without Disaster Girl, but, you know, there's only one team, right? This is what I always like tell my clients. There's only one team. Nobody cares if a systems engineer says to me like, well, that's not my problem, that's the development team's problem. It's everybody's problem, right? The customer doesn't care if the dev team didn't get something done or the ops team doesn't get something done. That doesn't matter to them. What they care about is the product. That's what we're going for in DevOps. We want really happy customers with the product so they can feed stuff back in, and, you know, all of Gene Kim's second way of DevOps. But there is only one product. So there is no them and us. It's just us. And so how do we make these changes? How do we encourage people? Like, it's one thing to say, hey, you should roll out the contact hypothesis or whatever, but like, what are the ways that we can actually change people? And so Jonathan Swift's quote is, it's useless to attempt to reason a man out of a thing he was never reasoned into, right? And so what it turns out is, you know, when we're doing the contact hypothesis stuff from Allport and things like that, what we're trying to do is show each other how we're the same. We're not making rational arguments. We're not like, you know, quoting the latest scientific whatever at people. You know, a lot of people talk about this being like winning hearts, not minds. And so I used to work with this guy, Walter. Walter's a great guy. I really like him. I've worked with him at like at least 2 companies at this point. And I was trying to get Walter to bring his engineers to a DevOps conference that I was putting on. And I went to Walter and I was like, hey, I'd really appreciate it if you brought your software engineers. This would be really great for the conference or whatever. And he said, well, Dave, I don't know. He's like, I've heard that in DevOps, the engineers have to be on call for their code. I was like, well, yeah, that's, that's one model for sure. Like, we could definitely do that. And he's like, I got to tell you, man, he's like, my engineers, like, nope, none of my engineers are going to want to get woken up at 3:00 in the morning. And I said, Walter, none of my engineers want to get woken up at 3:00 in the morning either, because obviously I'm coming from the operations side. And he's like, oh, I get it. Yeah, we'll be at your conference. Right. And I could have like gone and said, blah, 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 Gene Kim, Jez Humble, like Nicole, Fosgren, like I could have said all those things and come to him with all these arguments from the State of DevOps report. But instead, I went with empathy. I went with him realizing that the desires of his group are the same desires as the desire of my group. And that's how we were bringing the organization together. And so this stuff is real, right? These feelings that we have, when these things are activated in our brains, like these emotions, they're real. And so there's been a lot of research around pain in the laboratory. And, sorry if that makes people upset, but like pain is something that's very easy to elicit in a laboratory setting. You hook somebody up to a shock machine, you give them a shock, they feel pain. We can measure that. Like we can measure that in our brains. And like, comedy would be a great thing to have in the fMRI scanner, but like not everybody thinks the same things are funny. But everybody thinks that pain is mostly not funny. And so if you could have a favorite neuroscientist in the world, my favorite neuroscientist in the world, Tanya Singer, has done a lot of cool experiments, but one of them is she took men and women who were coupled, boyfriend and girlfriend, and she put them in the scanners and she was scanning them, and she would give an electric shock to one of the people in the scanner. And it turns out that when the women were in the scanner, whether it was them who got the shock or it was their boyfriends who got the shock, they would get activation in the in the dorsal anterior cingulate cortex region of the brain. If the women were the ones getting shocked, they'd also get activation in some sensory areas. But these women could actually say to their boyfriends with a straight face, "I feel your pain." And this pain is so real that they did this other experiment, another group called Cyberball. And in Cyberball, you lie in the scanner and you're playing a ball game with two people who are supposedly in other scanners in other parts of the world. And during this game, in the beginning, everybody's like cooperating and playing or whatever. And at some point, the two other people, let's say on the internet, stopped throwing the ball to the person who's in the scanner, who's the subject in the scanner. And when these people got this rejection, they actually had increased activation in their dorsal anterior cingulate cortex, the same regions that we feel for pain, just like real pain. And the craziest part about that is if they gave people Tylenol before they went into the scanner, they had reduced activation in the cingulate cortex, dorsal anterior cingulate cortex. That just proves like how real this stuff is, right? This is stuff that we actually feel. And so what can we do about stuff like this? That now that we know that these kinds of feelings are actually real and we can influence them, right? And so Dr. Lieberman, who was on our quote before, says, positive social regard, or what we'll call empathic concern, is a renewable resource. Rather than having less of something after using it, when we let others know how we value them, both parties have more. So we can actually up our empathy by expressing gratitude and things like that to other people on other teams. So if the engineers, the developers stay up all night fixing some bug that operations found, we need to go in and thank them for that. We need to show them how much we appreciate that. And we're not giving something up by doing it. We're actually building more of a connection between the two teams, and both parties will feel better after having that interaction. So we need to praise more. We need to activate those opioid and dopaminergic receptors. Because what we're trying to do is increase empathic concern and lessen empathic distress. We don't want to drive experience sharing. We don't want the network engineers to be up all night and be miserable. And then when the sysadmins come in the morning, then the sysadmins are miserable. We don't want to share that around. What we want to do is we want to drive this pro-social concern that we were talking about. We want to make it so that if anybody is having any problems on any of the teams for what we're delivering, we want everyone to chip in and help out together and try to build something better, right? And that's our DevOps. So we talked about things at the team level. What about at our individual level? So stress is a huge thing right now, especially there's a lot of us who are locked in our homes. There's a global pandemic going on. There's all kinds of things that are happening that are causing stress, right? This is something that we have in our jobs. It's something that we have in our lives. And so what do we know about this? We know that decisions directly after stress reveal increased generosity towards socially close but not distant others. So when we're stressed out, we're really only able to empathize as much as possible, whatever, with people who are close to us. And we don't want that, right? So in our work environments, we actually want to try to reduce stress as much as possible to allow for more collaboration to happen in between teams. We know that emotional contagion of pain in humans occurs in friends, but not in strangers. So if we see like other people on the, network engineering team that we're on who are struggling, who are in pain, we're going to feel that a lot more than we'll feel that like maybe for somebody else. But stress reduction in humans can elicit emotional contagion of pain in strangers. So if we can actually reduce stress, if we can do things to encourage people to like get enough sleep, spend enough time with their families, get enough exercise, all the things that are responsible, to take care of themselves, then they have a much better possibility of recognizing pain and distress and problems with strangers. So this suggests that stress is a key to emotional contagion and therefore is a fundamental building block of empathy, which is a fundamental building block of empathy. So we need to learn to take care of ourselves first, right? Because burnout inhibits empathy. And if burnout inhibits empathy, then burnout inhibits DevOps. And so we're not going to get as good results for our customers and things like that if we have like a really stressful work environment. So you want to build more in-group, we're going to get more performance, and we're going to do things like in that common in-group identity model. And since we're on, an online talk, I don't usually have this slide, but I think it's important to talk about. So, we have the webcam here, right? And a lot of people are going to go back to their distributed teams or newly distributed teams, should I say? And they're going to be involved with, what's going on between them and other people and things like that. And so what do we know about having this webcam on or whatever? Well, we know that perceivers want to be evaluated positively by others. And the presence of another mind can therefore increase socially desirable behavior. That means if people on your teams turn on their webcams, they're going to always want to be evaluated positively by others. So they're going to just elicit more positive behaviors as a result. Knowing that other people can see you just drives better behaviors. And so Jamil Zaki has a book that just came out that I really like called The War for Kindness. And he talks about the need for empathy in our world. And things like that. And he discusses an experiment that he was involved in where they were trying to figure out whether or not VR, virtual reality, could increase someone's level of empathy. Because, actors do this all the time, like method actors and stuff like that. They put themselves into the, into the mindset of whoever they're method acting, where, us normal average humans don't get to do that very often. But they thought VR might be a way to do this. And so they, had people read things and they had people do VR things, and those are two separate groups. What they found was when they were doing this simulation about homelessness, and then this person and the people in the VR situation got to experience homelessness like from the point of like what it's like to go through a day as a homeless person or whatever, they found that even months later, these people had a higher chance of supporting like measures, ballot measures to like help homeless people and things like that, than the other people who maybe had just read stuff. So we don't even need to be in the same place, right? We don't need to be in the same office next to each other to be able to utilize things like, our webcams and all this other communication. You hear all these people who are super happy they were on a Zoom room with their family or whatever. We can do this even though we're sort of isolated to ourselves. So sort of my ask of you, like at the end of this, is make connections. Like you have your cameras, turn them on. Like you're going to be in this conference. We have a whole day 2 of the conference to make connections. So go out, go into the hallway track rooms, like ask people, who's doing this? I want to talk about this. This thing is important to me. And make these connections with people that maybe you've never met before, right? You can make connections with people all over the world at this conference in a way that you could never do otherwise. And you have this. This is a natural ability of who you are. This is built into you as, the ability to empathize and understand other people. This is your default network. This is what your brain wants to do. So with that, like really, thanks for everybody for listening, and I hope we have a great day 2 of the conference.
And thank you, Dave. It was I think everyone really enjoyed that. There's a lot of conversation going on in the machine learning track for that. So if you wanted to maybe catch up with it, but really, that's a great way to kick off this whole day of sessions. I think for people to connect and be with each other and like exercise this empathy muscle. Let's all grow that together.